Okay, the Chapter 6 review, the test. So, what's happening right there? Here are the formulas you're going to need to know. Right here we have the Pythagorean theorem. Okay? Only for 90-degree triangles. Only. Here in the middle we have the Law of Cosines. We will only use two sets at a time. So A and B, B and C, A and C. This is the area formula, triangle. Right here we have the Law of Cosines. Here's when you're solving for a side, hence the little a. And here's where you're solving for the angle. And since you don't know the angle, don't forget you will have to do the inverse cosine. Over here, we have a 45, 45, 90 triangle. Remember, that is an isosceles triangle, two equal sides. Hence, everything is radical 2. So, you go back and forth with a radical 2. If you're going from the hypotenuse, which is the longest side, to one of the legs, which has to be shorter, you're going to divide by radical 2. In which case, most likely, you'll have to rationalize the denominator. If you're going from the leg to the hypotenuse, you're going to multiply. So either way, you're going to multiply or divide by radical 2. Now, notice here we have a 30, 60, 90 triangle. 3 different size of angles. Hence, 3 different side lengths, which makes it a scalene triangle. And since it has 3, this one uses the radical 3. Now remember, it helps to label. You have a short side, short leg, and a long leg, and the hypotenuse, which is always the longest. Okay? So short is baby bear, long leg is mama bear, and the hypotenuse is papa bear, the biggest one. When you're going from short to hypotenuse, you're going to multiply or divide by 2. That's the 2s. When you're going back and forth, between the short and the long, you're going to multiply or divide by radical 3. Now when you divide by radical 3, you'll have to rationalize. Okay, simplifying radicals. Whenever you see this, and it says no decimals, then don't put in your calculator and get decimals. You need to simplify the radical, which means you're looking for perfect squares. So your square numbers are 2 times 2, 3 times 3, 4, 5, 6, 7, 8, 9, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, and 15 squared. That should cover it. What you're doing is you're looking to see if any of these numbers go into these numbers underneath the radical. And I always suggest, because you can go small to big, but you might have to do it twice. Always start where you're at. So 72 is right here. Now hopefully you don't have to type that in the calculator, because obviously 60 and 60 is 120. So there's no way 64 is going to go in evenly to 72. And even 49, that's practically 50. That's 100. So if you want to take your calculator, it's not going to take but a few seconds. Divide. If you get a decimal, keep going backwards. But if you divide by 36, you find out that 36 times 2 is 72. But we're not dealing with 72, are we? We're dealing with radical 72. So that's radical 36 times radical 2. I always put my perfect square number first, just a habit, because then when I take and simplify that, I I end up with 6 times radical 2, and that's my answer. Number 2 is kind of a trick problem, because 143, you can divide by 121, and 100, and 81, and 64, and 49, and 36, 25, 16, 9, 4. And you'll get a decimal every time. That's because this is already simplified. It can't go any further. 240. Again, take your calculator and start, with 121 and 121. So 240. Sorry, calculator's messed up. 240 divided by 121 is almost 2, but not quite. It's a decimal. 240 divided by 100. Well, 100 times 2 is 200, and then 300. So that won't work. How about 81? 240 divided by 81. Decimal. Close to 3. 240 divided by 64. Decimal. Close to 4. 240 divided by 49. Close to 5 with a decimal. 240 divided by 36. Decimal. 25 obviously, because it's not going to be, it has to be 25, 50, 75, or 100. So how about 16? There we go. This breaks down to radical 16, the perfect square, and radical 15. Square root of 16 is 4. 4, radical 15 is your answer. Now, this next one throws people off sometimes. So you got to remember, there's already a number out here. You might want to circle this so you don't forget it. That number means 5 times radical 60. So when I break this down, okay, and it's going to break down into radical 4 and radical 15. But that's for the radical 60. You can't forget this 5 is here. So whatever we get, we're going to have to multiply by 5. So square root of 4 is 2, so don't forget this 5. Keep writing it if you have to. 5 times the square root of 4 times radical 15. This gives us 10 radical 15, and we're finished. Okay? Right here, this means negative 9 times the square root of 36. Well, look, 36 is already on our list. That's 6. So this is just negative 9 times 6, which is negative 54. Okay, now multiplication. There's 2 ways to do this problem. Technically, you do the outside numbers and the radical numbers. So if I do that, I get 2 times 6 is 12, and 8 times 4 is 32. So radical 8 times radical 4 is radical 32. Now I look at my numbers, and I see what goes into 32. And that's 16. So radical 16 and radical 2. And don't forget the 12. Well, square root of 16 is 4. And 4 times 12 is 48. Radical 2. And that's my answer. Like I said, there was another way to do this. If you happen to notice that square root of 4 is 2, it is a perfect square, I can simplify that so it looks like this. 2 times radical 8 times 6 times 2. Well, then that's 2 radical 8 times 12. And then I do 12 times 2. I get 24 radical 8. But then guess what? The 8 breaks down to radical 4 radical 2. And this equals 2. And guess what? 2 times 24, 48. So, a couple different ways to do it. That may look like more work, but you probably do most of that in your head. I'm just trying to show you how it works. But either way is fine. Okay, 6 over radical 12. I want to rationalize. So I'm going to multiply by radical 12 over radical 12. Which gives me 6 radical 12 on the top, and on the bottom I get 12. Because remember, a radical times itself is that number. Because radical 12 times radical 12 is radical 144. And the square root of 144 we see over here is 12. Now, at this point, I need to reduce 6 and the 12, which gives me 1 radical 12 over 2. But I can't stop there. Radical 12 has a perfect square in it, and that's 4. So, square root of 4 is 2. So that gives me 2 radical 12 over, sorry, that's just silly. That gives me 2 radical 3 over 2. And what happens to the radical 2's? They cancel. This simply simplifies to radical 3. Number 7 simplifies all the way down to that, radical 3. Okay. Radical 3, radical 3. On the top, I get 3 radical 18. I only multiply the radicals. And at the bottom, I get 3. Well, what happens to those 3's? They cancel. But I'm not finished yet, because radical 18 breaks down to radical 9 and radical 2. Again, you look over here on the list, 16 doesn't go in evenly, but 9 does. And the square root of 9 is 3, so that leaves me 3 radical 2. Now, number 9, there's 2 ways to look at this. The short way is just to know you're going to square the 5 and square the radical 2. Well, 5 times 5 is 25, and radical 2 times itself is just 2. It's also radical 4, which is just 2. And that leads us to 50. The longer way is to write it out like so. 5 radical 2 squared means times by itself. And then you do your outside numbers and your radicals, which will lead you right to here. That's page 1. Okay, Pythagorean theorem. You all know how to do this. Remember, I would go through first off on all these and find your hypotenuse, just to keep yourself straight and keep yourself honest. Okay? I might even put a C to remind myself. You can put height to remind yourself. Any of these things, if you know you forget the order, or you have messed this up in the past, or you've struggled with it, some of these clues just to keep you on track. Now, the legs don't matter. I can say x squared plus 6 squared, or 6 squared plus x squared. It makes no difference. If you want to use a and b instead of x, that's fine. X squared plus 6 squared equals 8 squared. X squared plus 36 equals 64. Notice it says leave all answers exact, no decimals. Minus 36, x squared is 28. Now I take the square root of both sides. And now I go back to my list. Radical 4, radical 7. So x is equal to 2 radical 7. 13. X squared plus 10 squared equals 26 squared. X squared plus 100 equals 676. Now, I must warn you, and some of you did this on the first quiz, please be careful not to try to do too much in your head, because a lot of people had the habit of going to 776 now. Remember, you're subtracting 100 to move it over, which makes x squared equals 576. And that's actually a perfect square number. You may not know it, but I would always, especially when you have big numbers, see if you can square root it evenly. Then do the trick I taught you with going backwards through the perfect squares. This actually is 24. Number 11. Again, x squared plus 11 squared equals 15 squared. X squared plus 121 equals 15 squared, which is 225. We subtract the 121 and get x squared equals 104. And we test, backwards, and we divide by all the different numbers. And when you do that, take square root of both sides. 104 breaks down to radical 4 and radical 26. And 26 just breaks down to 2 times 13, and those are both prime numbers. So x is equal to 2 radical 26. That is simplified. That's an exact answer, no decimals. If you leave it as radical 104, you'll get points, just not all the points. So always see if you can reduce. Okay, 2 ways to do number 14. The directions say do Pythagorean theorem, so you must do that. 4 squared plus 4 radical 3, careful here, equals x squared. You've got to put the 4 radical 3 in parentheses. So that gives us 16 plus 16 times 3. Remember, radical 3 times radical 3 is 3. Equals x squared. So that's 16 plus 48. And that's 64. And the square root of that is 8. But if you did not have the directions that it had to be done with the Pythagorean theorem, notice, if this is 4, and this is 4 radical 3, that means you multiply by radical 3. Well, when do we do that? We do that when this is a short leg and a long leg of a 30, 60, 90 triangle. And then if you think about how do I go from the short leg to the hypotenuse, I multiply by 2, and there's my 8. So if you were not limited by the directions on this problem, you could have done that in one jump if you saw it. So always look for the options. Again, number 12, if you didn't have these rules, obviously that's this isosceles triangle. How do I go from isosceles to the leg to the hypotenuse? I multiply by radical 2. So this is 7 radical 2. But the directions say use Pythagoras. So here I go. Well, that's 49 plus 49. So x squared equals 98. My square root, obviously this is going to break down to 49 times 2, because I just added 2 of them, right? And the square root of 49 is 7. 7 root 2. Okay, 30, 60, 90. Again, I would take the time every time to first go through and label my hypotenuse on every one of these. My first step. My second step is to finish. If this is 30, this is 60. If that's 60, this is 30. 30 gives me 60, and 30 gives me 60. My next step in labeling, and the last step, is 30, that's the short side. 60, that's the long side. And I would do this. I mean, it doesn't take that long, and it helps keep you from making mistakes. 30 over here is my short side. 60, that 15 is my long. Obviously, the hypotenuse is the long, yes, but we're talking about short and long leg. 30, this side is opposite, so that's my short leg. 60, opposite is my long leg. Now that everything is going and labeled, now I remember, try to keep it straight. Short and hypotenuse is multiply and divide by 2. And short and long is multiply, divide by radical 3. If you're getting bigger, multiply. If you're getting smaller, divide. So, I solve for all the missing sides by using this rule. I have my short, 9. To go to my hypotenuse, I double it, and I get 18. To go to my long, I multiply by radical 3. 9 radical 3, I'm finished. Okay. To get the hypotenuse, I need the short side, which is right there. To get the short side, I start at the log, which means I have to go this way and divide by radical 3. So 24 divided by radical 3 means I need to rationalize. That gives me 24 radical 3 over 3. And then I simplify, and that gives me 8 radical 3 for this side. And then from short to long, to hypotenuse, I just double the 8. 16 radical 3. Okay? Number 16. I'm at the long again. I got to get to short first. So that's 15 divided by radical 3 again. I'm going from the long to the short, so I divide. I have to rationalize. 15 radical 3 on the top and 3 on the bottom. Nicely it cancels. 3 goes into 15 5 times. So that's 5 radical 3. That's my short side. To go to my hypotenuse, I just double the 5. The radical stays the same. I don't double that. It's not 10 radical 6. You just are doing 2 times. Think about it. 2 times 5 radical 3. Outside number, outside number. And number 18. Again, this time I have my hypotenuse. This is a little bit easier. I go from my hypotenuse to my short is just divide by 2. 13. And then to go to my long is just tack on a radical 3. That's all I've got to do. Number 19. First off, I need to make this into a rectangle. This is 13 right here. If I bring this down, that means this section right here is 13. If this entire section is 20, that's 20, that's 13. What is left here? And no, it's not drawn to scale. 20 minus 13 is 7. So that side is 7. Notice I have a 90-degree angle. So there's a 90 and a 60, which makes this 30. Which makes 7 my short side of the triangle. Short leg. There's my hypotenuse. What do I do to get that? I just double the short. 14. And then from short to long is 7 radical 3. And that's the same for this. Because this line is that line. Right? These are the same. So this long leg of my triangle is 7 radical 3. This side of the rectangle is 7 radical 3. And there you go. X and Y are solved. Okay, 45, 45, 90. I don't really need to put this, but I will. I want to mark these to remind myself. Hey, look, 2 sides. The key to 45, 45, 90s is radical 2. If I'm going bigger, I multiply. If I'm going smaller, I divide. Well, what am I looking for here? I'm looking for the legs. I already have the longest side, so I need to divide by radical 2. At which point I need to rationalize. That gives me 8 radical 2 over 2. 2 goes into 8 4 times, so both of my sides are 4 radical 2. And yes, label both of them, please. at least label one and put these marks. I will accept that too. Okay? I have my hypotenuse, right? Right there, hypotenuse. 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 To go from the hypotenuse to the leg, I divide, there's my fraction bar for divide, by radical 2, because there's two equal sides. I have to rationalize, which gives me 16 radical 2 over 2, which nicely again cancels, and I'm left with 8 radical 2 for both of them. Okay, it doesn't say 45, but these are marking equal, which means they have to be 45. Because I used 90 up here. So these are my two legs, and this is my hypotenuse. If this is 11, that's 11. And to go bigger, I just multiply, which means just tack on a radical to it. That's it. 24. I have my hypotenuse. I'm trying to go to my leg, which means I take my hypotenuse and divide by radical 2. Now radical 2 does not go into radical 3. So therefore I need to rationalize. Now when I do, remember, radical times radical. So I end up with 6 radical 6 over 2. The 6 and the 2 cancel. 2 goes into 6 3 times. And I end up with 3 radical 6 for both. 22, where's my hypotenuse? Right there. This is 45. These are equal. So this is 6 radical 2. I'm going towards the bigger side. So I'm going to take 6 radical 2 and multiply by radical 2. This is special. Remember, it's radical 4, or just 6 times 2, which is 12. Okay, SOHCAHTOA. Remember what this means. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, here's Grover down here. Grover's looking all the way over there. All the way to the opposite side. Here is my hypotenuse. I label that. Well, O and H, right there. Sine of 41 equals, opposite over hypotenuse. I find my variable. What's happening to it? It's being divided by 8. I don't want it split up 8 ways. I want it back to the original, so I multiply by 8. That cancels the 8. That's why I multiply. Because the x that I want alone is being divided up 8 ways. I want to put it back together. One whole x. When I do that, I get x equals 5.248. And notice it says angles nearest whole number, sides the 3 decimal places. So there's 1, 2, 3. Okay, number 26. Here's Grover. The way over there is my opposite. Right here is my adjacent. I'm not using my hypotenuse. If I'm not using the hypotenuse, I can't be doing sine or cosine because they both have an h in them. So this must be tangent. Tangent of 55 is equal to opposite over adjacent. Again, x is being split up 11 ways, so I multiply by 11 to undo that. I just type in my calculator, 11 times tan 55, and I get 15.710. And I just put the 0 there because I could just put 71, but that shows 3 spaces. Okay, so here's Grover over here. The 7 is right here, right next to him. So that's adjacent. And we know this is our hypotenuse. So adjacent and hypotenuse, AH is cosine of 37 equals adjacent over hypotenuse. Now this time the x is on the bottom. We need the x on top. Remember, the long way, I'm going to show it then erase it just because of space. The long way is to multiply by x. And if you want to fast forward, you do the shortcut, that's fine. That cancels the x's here. So you end up with x times the cosine of 37 equals 7. But to get x by itself, we need to divide by the cosine of 37 on both sides. I guess I won't erase it. But basically what happens is, if you look at the original problem, these two just switch. So if I just say x on the outside equals 7 over cosine of 37, I get to the same place just a little quicker. It's just a shortcut. If you need to do the steps, that's okay. It doesn't take that much longer. But you only do this when x is on the bottom, because you need it on the top. Because x on the bottom is 1 over x. We don't want 1 over x. We want x over 1. So we need to bring it to the top. Okay, and then when you type that in your calculator, x divided by the cosine of 37, you just type it in exactly that way, you get x equals 8.765. 28. I have my hypotenuse. I find that right away. Put an H for hypotenuse. Here's Grover. Oops. I need x and y. I need to find them both. Well, x is right here. Y is over there. So opposite and adjacent. So we have to do two problems. So let's go in alphabetical order. X, which is adjacent. Adjacent hypotenuse is cosine. Cosine of 40 equals adjacent over hypotenuse. And I'm just going to set up the other one to see how similar it is. Sine, which is opposite over hypotenuse. Notice both times my x and my y are in the top. So I need to get rid of the 14 on both problems by multiplication. So when I type in 14 times cosine of 40, I get x is equal to 10.725. And over for y, when I multiply by 14, and I type in 14 times the sine of 40, I end up with 8.999. 29. Notice I don't have my hypotenuse. If I don't have a hypotenuse, I can't be using sine or cosine. No ahs or ohs. It's oa. So here's Grover. He's looking over there to the opposite side, way over there, and right here is adjacent. Right here. Right next to him. So that's oa. Tangent of 26 equals opposite over adjacent. Again, my x is at the bottom, so I need to switch places. 10 over tangent of 26. When I do that, I just type in my calculator that way, and I get x is equal to 20.503. Remember, you can pause any time, you can go back, fast forward, wherever you need to look. Use the law of sines. Well, I need to find my magic fraction. There it is. I have an angle opposite the side. That is my magic fraction, or my reference fraction. So I do sine of 67 over 42, because those are the two things I know. Now notice where my x is, opposite 33. So I put sine on top again, and I put the x on the bottom. Now, what am I trying to find? X, means I'm going to multiply these two and divide by sine of 67. And I literally just type in my calculator, 42 times the sine of 33 divided by the sine of 67. Now, you got to be careful. You have a couple choices. You can type in 42 times sine of 33, enter, then divide by sine of 67, enter. Or you can do 42 times sine of 33, but make sure you close the parentheses, then the division sign, sine of 67. It makes no difference. X equals 24.85, and again 0 because it is just 0. Okay, 31, I need to find my magic fraction. There it is. Sine of 57, I know that, corresponds to side 13. The one I don't know is right here. Sine of x. It's inside, so it's a variable. I mean, it's an angle. Which I mean, I need to know that I'm going to do inverse at that point. And there's the side. So what am I trying to find? This. Which means I multiply those two and divide by 13. Now when I do that, remember, I get a decimal. I apologize. I forgot. I told one class, and I didn't tell the other one, you need to switch these. Because otherwise it doesn't work. The decimal you come up with does not work. Sorry. Sine of 57 over 19 equals sine of x over 13. When you do that, you get the proper decimal of 0.5738. Now you type in inverse sine, 0.5738, and you get 35 degrees. Don't forget the degree symbol when you're doing degrees. Okay, 32, we're using the law of cosines. Notice here, we're solving for a side, which means we're going to use x equals. These are our reference numbers for the sides. Square root, big long square root. 23 squared plus 22 squared minus 2 times 23 times 22 times the cosine of this angle right here. The included angle between that side and that side. Now, I like to take baby steps. I like to do this first part, 1013 minus 346.124, which gives me x is equal to square root of 666.876, depending where you round. And that gives me a side of 25.824. Which makes sense, 25 squared is 625. Now notice on 33, I'm solving for an angle. So this time I'm doing cosine of x equals. Now remember, this is the one that comes last. These two go on the bottom and go first on the top. So 13 squared plus 17 squared minus 20 squared. Make sure this is minus. If you put plus, it's going to mix everything up. And on the bottom, 2 times 13 times 17. You don't use the 20 in the bottom. Okay? Only the sides that make the included angle. When you do that, you get cosine of x equals 58 over 442. And that, you get a decimal or just leave it like that. Then do the inverse cosine of 58 divided by 442, and you get 82 degrees. Use the formula to find the area. Remember, simple formula. Area is 1/2 the one side that makes the angle times the other side that makes the angle times the sine of that angle. And when you do that, you get area of 48.096 And remember, it's units squared. Okay, included angle. Area equals 1/2. You can put 0.5 if you want in the calculator, whatever. Times 23 times 18 times the sine of 81. Area equals 204.454 units squared. Okay, cofunctions. The sine of an angle is equal to the cosine of the complement. Remember, that means it adds up to 90 degrees, which is key here because all we're going to do for these is take 90 minus 45, 18, 4x. All right? So 90 minus 45 is 45. If you type sine 45 in the calculator, you'll get 0.7071. If you type cosine of 45, you'll get the same thing. 38. 90 minus 18 is 72. The cosine of 18 is 0.9511. Guess what the sine of 72 is? Same thing. Sine of 4x. Okay? Well, that's going to be 90 minus 4x. And depending on what x is, we're not going to do this part because we don't know what x is. Okay, here we're given the decimal. What you're going to do is we're trying to find the sine that goes, the sine of what angle gives us this decimal. How do we find an angle? Inverse. So if you do inverse sine, second sine, 0.5299, you get 31.999. Let's just say 32 degrees. If you do inverse cosine of 0.5299, you get 58.001. Let's just say it's 58. What do you know is about 32 and 58? They equal 90. 0.6691. If you take the inverse cosine, you get 48 degrees. If you take the inverse sine, you get 42 degrees. Guess what they add up to? 90. Okay, everybody's favorite. Word problems and drawing. You have a 15-foot house. Okay, 15-foot house. 15 feet tall. A 40-foot tall tree falls against the house. How far is the base of the tree from the base of the house? What is this measurement right here? Well, that is simply right angle A, B, C. 15 squared plus B squared equals 40 squared. 225 plus B squared equals 1600. B squared equals 1600 minus 225, which is 1375. Now, it says special triangles have exact answers, in other words, reduced. This is not a special triangle. We don't know what it is. So we're just going to take, it's a real world problem, so we're going to take the square root and get 37.1 feet. Don't forget the label, feet. If you would reduce that, just for the heck of it for more practice, this breaks down to 25 times 55. Okay? 55 doesn't break down to anything but 5 times 11, both prime. So this reduces to 5 times root 55 as a reduced radical. A boy builds a ramp 12 feet long. That looks like 13, doesn't it? 12 feet. and stacks on top of bricks, that are 6 feet. What is the angle right there? Well, here's Grover, looking way over there, opposite. There's our hypotenuse. Opposite hypotenuse is sine. Sine of what is 6 over 12? You take the inverse sine, you get 30 degrees. A girl standing next to a building. That's an antenna. The girl standing 50 feet from the building. Okay? There's a 75-degree angle to look at the top of the building. How tall is the building? Well, here's Grover looking over there, opposite. 50 is right here, adjacent. No hypotenuse, that means tangent, TOA. The tangent of 75 is equal to the opposite over the adjacent. 1x by itself, so we multiply by 50. That cancels. When I type that in my calculator, I get 186.6 feet tall. And we're almost there. A rectangle has a height of 8 and a length of 12. Find the length of the diagonal. Well, if it's a rectangle, it's 90 degrees. Which means we have A, B, C. 8 squared plus 12 squared equals C squared. 64 plus 144 equals C squared. C squared is equal to 208. If I was going to break this down, it would be radical 16 times radical 13, which would give me an answer of 4 root 13. If I just took the square root of 208, it's 14.4. A rectangle has a length of 10, a diagonal of 18. Find the height. Same problem, except this time we don't know what are the sides. 8 squared plus 10 squared equals 18 squared. 8 squared plus 100 equals 18 squared, which is 324. Subtract 100. Don't forget this. It's subtracting. 8 squared equals 224. If we're going to break this down to find the square root, it'd be 16 again, but this time times 14. So that would be 4 radical 14. If we just took the square root and got a decimal, it would be 14.97. A square, a horrible square, has a diagonal of 12. Well, if it's a square, it's 9 degrees. It also cuts into 2 isosceles triangles, which means this is 45 and this is 45. As soon as I hear the 2 sides, I know I'm working with radical 2. Since I'm going from the longest side to a leg, I'm going to divide 12 by radical 2. As soon as I divide by a radical, I need to rationalize, which gives me 12 radical 2 over 2. That cancels, leaving me 6 radical 2. And since this was a special triangle, I'm leaving it like that, not a decimal. Equilateral triangle. An equilateral triangle means 60, 60, 60. I drop an altitude down from the vertex, straight down, making 90 degrees. Well, this is 90 and that's 60. What does that leave here? 30. Which makes this my short side, which makes this my hypotenuse, and makes this my long. If the altitude has a length of 12, That's my length. That's my long side, my long leg. Well, to find the short leg, I first need to divide by a radical 3. So the 30, 60, 90 has 3 different sides. It's scalene. I then rationalize. I get 12 radical 3 on the top and 3 on the bottom. I divide 3 into 12 and get 4 radical 3. So my short side is 4 radical 3. Now I'm going from my short to my hypotenuse. All I do is double the 4, and I get 8 radical 3. And that is it. And that is your review at just under 51 minutes.